Welcome to the deep dive. Okay, picture this with me. You've got this 40-year-old suburban guy.
Right.
Pretty normal life, you know, married 15 years, kids, the whole standard setup, ordinary.
Almost boringly normal, maybe.
Exactly, until, boom, one day, just completely out of nowhere, he punches a coworker right by the water cooler.
Whoa. Okay.
Just totally bizarre, not him at all. Then, maybe 3 months later, his wife finds out he's having an affair.
Oh, boy.
Yeah, and get this, with a 16-year-old checkout kid from the grocery store.
Oof. That's quite a turn.
And it doesn't stop. Another 3 months, and he embezzles all the money from his job, vanishes, poof, gone.
Wow. Okay, so that's quite a spiral.
Right, so when you hear that story, what pops into your head? Is this guy just, I don't know, a monster? Having the world's worst midlife crisis?
Yeah.
Or is it something else?
Well, and this is where it gets really interesting, that exact profile you just described. The weird aggression, the inappropriate sexual stuff, the impulsive, like stealing money.
Yeah.
Sometimes, believe it or not, that can actually be traced back to a very specific biological cause, like a single gene mutation.
A gene for that behavior.
Yeah, leading to a specific kind of neurological disease. So what looks like a moral failing or, a crisis could actually be biology.
That completely changes how you look at it, doesn't it? What we rush to label as just bad character.
Exactly. It might have roots we just don't typically consider.
And that story, I mean, it sounds extreme, but it's a perfect way into what we're doing today, isn't it?
It really is.
So our mission here in this deep dive is basically to grab this stack of sources from Stanford's Bio 150 course, Human Behavioral Biology, and really unpack this whole tangled relationship, biology and behavior. We're not just listing facts, though. The goal is to pull out the big insights, maybe challenge some assumptions you might have, get a more nuanced view of why people do the things they do, especially the complex stuff, social behavior, abnormal behavior.
It can feel really complicated,
Yeah.
messy even.
Totally messy, but hopefully we can make it accessible and honestly pretty fascinating too.
Agreed.
Okay, so let's start with a little puzzle. I've got 4 things that seem totally unrelated. Ready?
Okay, hit me.
1, a woman having her period. 2, someone with a brain tumor. 3, a person who eats a ton of junk food. And 4, someone taking anabolic steroids.
Period, tumor, junk food, steroids. Okay. What's the connection?
What ties all those wildly different things together? Any ideas?
Well, they're all internal states, physiological things affecting the body.
Getting warmer.
Do they maybe affect behavior in extreme ways?
Bingo. And not just affect behavior, but here's the kicker. All 4 of those have been successfully used in court.
Successfully?
Yes, successfully used in courts of law to essentially help explain why someone committed murder.
Wow. Okay, hold on. Successfully argued in a murder trial. That seems huge. It kind of flies in the face of how we think about responsibility.
Exactly. How does the legal system even deal with that? Tell me about those cases. That's wild.
It is wild, but it's happened. Take menstruation. There are actual cases where the fact a woman was on her period during a killing was part of a defense that led to, say, exoneration or a lesser charge. And the research does show, statistically, more female aggression around menses.
Okay.
Than brain tumors. Specifically, tumors messing with the amygdala that's deep in the brain,
Right.
involved in, aggression, fear.
Right.
People with tumors there have sometimes become uncontrollably violent. And again, that's been used successfully in court.
Okay, tumor makes some intuitive sense, maybe. But junk food.
The famous Twinkie defense. Dan White, San Francisco, assassinated the mayor and Harvey Milk. Part of his defense, and it wasn't the whole defense, but part of it argued his diet of sugary junk food led to blood sugar swings, affecting his mental state, his judgment.
The Twinkie defense, I remember hearing about that. It sounds almost ridiculous.
It does, but it was part of a diminished capacity argument that worked to some extent. And finally, anabolic steroids, roid rage.
Yeah.
We've all heard stories, right? Weightlifters having these outbursts of uncontrolled violence. That's also been linked in legal cases.
Okay.
So the big insight here, the really profound thing, is just how much our internal state, our physiology, can drive what happens upstairs in the brain. And therefore, our actions. It's not just character.
That's powerful. Body influencing brain and behavior so dramatically. So does it flow the other way too? Can our thoughts, our mind change our body?
Oh, absolutely. It's a two-way street.
Yeah.
Definitely. Think about this. Try it right now. Imagine you're lying down, calm, heart beating slow. Now think, my heart's not going to beat forever. My lips are turning blue, blood's slowing down, my feet are getting cold.
Okay, stop. Yeah, I can feel my heart rate pick up just thinking about it. A little bit anyway.
Just a thought. A purely mental event changes your physiology, heart rate, maybe palms get a bit sweaty. So yeah, this whole deep dive is really about that intertwining. Physiology, behavior, thoughts, emotions, memories, they're all constantly influencing each other all the time.
It sounds incredibly complex, though.
Right.
Which makes me think, you know how our brains like to simplify things? We categorize everything. Is that helpful here, or does it cause problems?
It's definitely how we operate.
Yeah.
We impose boundaries on things that are actually continuous. Think
Right.
about length. It's infinite, right? But we have categories like a foot long or 6 feet tall.
Or like a ruler length, yeah.
Or speed. Infinite possibilities, but we create a category like the sub 4-minute mile. Big deal, right? Or colors. It's just a smooth spectrum of light wavelengths, but we chop it up into red, orange, yellow.
We need those labels.
We do it because it makes information easier to handle, easier to store, easier to evaluate. You don't remember the exact wavelength, you remember it's orange? And studies show this. People remember colors better if they fit neatly into their language's categories. If you show someone a weird, squiggly shape that doesn't have a name, they have a much harder time remembering it later than if you show them a square.
So categories help us remember and process.
Yeah.
Makes sense. But I'm sensing a but coming. What are the downsides?
Oh, there's some big ones. A bunch of problems, actually. First, you tend to underestimate the differences within a category.
Okay, like what?
Think about sounds. In English, we clearly hear the difference between a B sound and a P sound, right? Bat versus pat.
Yeah, totally different.
But in Finnish, for example, they don't really make that distinction. It's kind of one category for them. I actually had this experience once. A Finnish urologist friend told me I should practice doing testicular biopsies on a bear.
On a bear. Seriously.
Seriously. It took a while to figure out he meant a pear, like the fruit, because for him, B and P were sort of in the same sound bucket. Misunderstanding within the category.
Okay, wow, that's a good example. Underestimating differences inside a category. What else?
Second problem. You overestimate differences across a boundary. Think about exams. Getting a 6.5 versus 6.6.
Oh, yeah. Huge difference.
Right.
Failing versus passing.
Right. Numerically, it's tiny. Just 1 point. But because we drew a line there, a boundary, we treat it like a massive gulf. The difference feels enormous.
We inflate it. Okay.
And the third issue is, when you get too focused on the categories, on the boundaries, you can completely miss the big picture.
How so?
Remember trying to memorize phone numbers? We're used to that 3-digit, then 4-digit pattern, right?
Yeah.
If someone gives you a number like 5551234, you're fine. But if they break that pattern, say 5551234, your accuracy just plummets. You're expecting that 3-4 category.
Well, it throws you off.
Or here's another one. Sequence. 4th, 14th, 23rd, 34th. What comes next?
4th, 14th. Difference is 10, then 9, then 11. Maybe 45th or 44th, following some pattern. I don't know.
See, you're thinking in mathematical sequence categories.
Right.
But if you lived in New York City, you might instantly say 42nd.
42nd. Why?
Those are subway stops on certain lines.
Yeah.
4th Street, 14th Street, 23rd, 34th, 42nd Street. It's a totally different category system geography, not math. Your math category blindness prevents you seeing it.
Huh. Okay, that's clever. So we get stuck in our usual boxes.
We all do. And these problems, underestimating within, overestimating between, missing the big picture, they become really critical when we talk about complex stuff, like the biology of behavior.
Right. So how does this apply to understanding, say, why someone acts aggressively or why they develop depression? We can't just put it in one box.
Exactly. Think about that chicken crossing the road again. Why did she do it?
To get to the other side. Or the rooster, you said.
Right, the rooster. So an endocrinologist might say, well, her estrogen levels were high, making her brain sensitive to rooster cues. That's the hormone bucket.
Okay.
An anatomist might say her leg muscles and pelvic structure allowed her to run. That's the anatomy bucket.
Got it.
An evolutionary biologist says, over generations, chickens that responded to roosters left more offspring. Evolution bucket.
Different explanations, different buckets.
All perfectly valid ways of looking at it. But the danger is falling completely into one bucket, saying, oh, it's all because of the hormones, or it's all genetic, or it's all about their childhood.
Right, picking just one cause.
And that's a core idea for this whole deep dive. Resisting that urge, realizing that any single factor, a hormone, a gene, a brain region, an experience, it's just like a snapshot. It's a convenient way to describe the result of everything that came before it, stretching back seconds, minutes, years, millennia, all the way to evolution.
So no neat buckets, just this continuous interconnected web of influences.
Precisely. We'll use the bucket terms because they're useful labels, but we have to keep reminding ourselves they aren't actually separate.
Okay, this idea of categorical thinking being problematic, it feels like more than just a cognitive quirk or a way to make bad scientific models. Does this kind of narrow thinking have, like, real-world consequences, maybe dangerous ones?
Oh, absolutely. And this is crucial. Why fight so hard against thinking in these neat little boxes?
Yeah.
Because history is littered with examples of where it led to, frankly, unspeakable damage,
Yeah.
and often driven by influential scientists.
Like who? What happened?
Well, take John Watson. Early 20th century, a founder of behaviorism. Huge figure.
Right, behaviorism all about rewards and punishments shaping behavior.
Exactly. He famously and very arrogantly claimed, basically, give him any healthy infant, raise it in a controlled environment, and he could make that child into anything: doctor, lawyer, artist, beggar, thief, purely through environmental conditioning.
Wow, that's extreme.
It's pathologically living only in the environment bucket, completely ignoring biology, genetics, temperament, anything internal, just rewards and punishments.
Could he actually try it?
Not quite like that, but his theories were hugely influential. And interestingly, after a scandal kind of pushed him out of academia, he went into advertising, became very successful.
Huh. So he couldn't turn kids into anything, but maybe he could make people buy stuff.
Seems like it. Make people buy all sorts of giga nonsense, as the source puts it. But the point is that extreme environmental focus was flawed and potentially harmful.
Okay, so that's over-relying on the environment bucket. Any others?
Then there's Agus Moniz, Portuguese neurologist. He invented the frontal lobotomy.
Oh, lobotomies. Yeah, that sounds bad already.
He genuinely believed that mental illness was just faulty wiring, bad synapses, and that by physically severing connections in the frontal lobe, literally cutting into the brain, he could fix it. Synaptic adjustments, he called it.
And people let him do this.
He won the Nobel Prize for it in 1949.
You're kidding. A Nobel Prize for lobotomies.
Not kidding. He thought it could cure mental disorders without failure. But the reality was, well, it was often massive criminal destruction of people's brains and personalities. That's pathologically living only in the brain wiring bucket.
God, that's horrifying.
It may be the most chilling example. Konrad Lorenz.
Lorenz. Wasn't he the guy with the geese imprinting?
That's him. Austrian ethologist, studied animal behavior. Famous for ducklings following him around. Looks like a kindly old professor. Nobel Prize winner too, actually.
Okay. So what's the dark side?
He was also a rabid Nazi propagandist.
What? The goose guy.
The goose guy. He took his ideas about animal behavior and genetics and twisted them to support Nazi ideology. He wrote about the need for the extermination of elements of the population loaded with drags.
Wild.
It's living pathologically in a fabricated race or genetics bucket, using science or pseudoscience to justify genocide. Millions died based on that kind of categorical thinking.
So these examples, Watson, Moniz, Lorenz, these weren't minor figures. These were giants in their fields, Nobel laureates.
Exactly. Not crappy fourth-rate scientists.
Yeah.
Hugely influential people whose narrow, categorical thinking caused immense, direct harm and shaped terrible societal views.
That really drives home why resisting those neat little buckets isn't just an intellectual exercise, it's ethically crucial.
It absolutely is. The stakes are incredibly high when we talk about understanding human beings.
Okay, so given those warnings and the complexity we've talked about, how do we actually do this? How do we study ourselves without falling into those traps? What are the big challenges we face?
I think there are three main intellectual challenges we have to constantly keep in mind.
Right, what's the first one?
First is remembering that sometimes, honestly, there's nothing fancy about us at all. We're just like any other animal.
We're just animals.
Pretty much. Take something called menstrual or ovulatory synchrony, the Wellesley effect.
Okay, what's that?
Well, back in the 70s, they noticed that female roommates at Wellesley College tended to synchronize their menstrual cycles over time.
Huh. I think I've heard of that phenomenon. Is it real?
It's debated in humans, but the mechanism is well understood in other animals. Like female hamsters totally do it. They release pheromones, airborne chemical signals that influence each other's cycles.
And hamsters synchronize their periods.
And goats, sheep, pigs. You can apparently buy pig ovulatory synchronization spray at like farm supply stores, maybe even 7-Eleven in some places, according to the source material.
Seriously, pig synchronization spray.
Okay, and here's the interesting part. In those hamsters, it's usually the dominant, more socially outgoing female whose cycle the subordinate one synchronizes to.
And the dominant one sets the pace.
Yeah. And guess what? The original Wellesley study suggested something similar in humans. The more socially dominant roommate tended to set the cycle for the other.
Wow. So that basic biological mechanism, maybe it's playing out on us too.
Yumi. The point is, sometimes our biology is just plain old animal biology. Our genome is like 98-point-something% the same as a chimp's. We shouldn't always assume we're unique.
Okay, challenge 1. Remember, we're sometimes just animals. What's number 2?
Challenge 2 is kind of the flip side. When we use the same basic physiology as other animals, but we use it in ways that are completely unique to humans.
Same biology, different purpose, like what?
Think about stress. The physiological stress response, heart rate up, blood pressure up, stress hormones flooding your system.
Yeah.
It's basically the same in us as it is in, say, a baboon facing a predator or a rival.
Okay, fight or flight stuff.
Right. But think about what triggers it in us. A baboon gets stressed by immediate physical threats. We can trigger that exact same intense physiological response just by thinking.
By thinking.
Yeah. Consider chess grandmasters. During a tournament, they're doing basically nothing more physically taxing than lifting their hand to move a piece, right?
Right, sitting in a chair.
But their blood pressure can stay elevated for 6-7 hours, like they're running a marathon. They can burn thousands of calories a day just through intense concentration and presumably stress.
Just from thinking about chess moves.
Apparently so. Or think about other uniquely human stressors. We can activate that same ancient stress response by contemplating our own mortality.
Okay.
Or by reading a news story about a suffering child on the other side of the planet. Or by feeling inadequate because you saw someone drive by in a really fancy car. Or even by deeply empathizing with a character in a novel.
A baboon isn't getting stressed out by a novel.
Exactly. So we have the same boring physiology. But the triggers, the context, the reasons we activate it are often utterly unrecognizable to any other animal. That's the second challenge. Understanding how we repurpose basic biology for uniquely human experiences.
That's fascinating. Same tools, totally different jobs. Okay, so challenge 1, or animals. Challenge 2, we use animal physiology in unique ways. What's the third one?
The third challenge is when we do things that seem to have no precedent whatsoever in the animal kingdom. Things that are just uniquely and sometimes weirdly human.
Things nothing else does, like what?
Well, think about human sexuality, for instance, and communication around it. The source gives this example. Imagine a couple. They come home, talk, eat, talk, go to bed, have sex, and then they talk about it afterwards.
Okay. Seems pretty normal for humans.
Right. But now imagine they do this every single night for a month. Still within the realm of human possibility, maybe.
Maybe for some, I guess.
But think about it from an animal perspective. First, very few animals engage in non-reproductive sex at all, let alone daily. Second, nobody else talks about it afterwards. The source jokingly says hippos would be repulsed by this behavior.
Huh. Okay, I see the point. Daily non-procreative sex plus post-coital chat is pretty uniquely human.
It points to things like our complex language use, certain aspects of our sexuality. And unfortunately, it also includes some darker, unique traits. Like the source mentions the profoundly damaging human tendency for some individuals to confuse sexuality with aggression. That seems to have no real parallel.
So areas where we're truly operating without an animal playbook?
Exactly, and understanding the biology behind those behaviors is the third major challenge. No easy comparisons to draw.
Okay, wow. So we've got the body-brain connection, the dangers of easy categories, the historical warnings, and these 3 big challenges. How does this deep dive actually put all that together? How do we use the course material to navigate this?
Well, the way we're structuring this, much like the course itself, is kind of in 2 parts. First, we introduce the different perspectives, the different buckets, if you will, as foundational tools.
So we learn about evolution, genetics, hormones, brain science, all that separately first.
Right. We get a handle on evolutionary theory, molecular genetics, ethology, that's the animal behavior stuff, neuroscience, endocrinology, which is hormones. We build that toolkit.
Okay.
But then comes the second part, which is where honestly the real payoff is. We take those tools, those buckets, and we essentially rip them apart.
Rip them apart? How?
By looking at specific, complex human behaviors. Things like sexual behavior, aggression, parental care, cooperation, mental illness like depression or schizophrenia, language.
And apply all the buckets to each one.
Exactly. We apply that multi-layered analysis we talked about. For any given behavior, we ask, okay, what does it look like? Objectively.
Step 1, observe.
Then, what happened in the brain milliseconds before? Neurons firing, circuits activated.
Okay, the immediate trigger.
Then what sensory input, sights, sounds, smells, triggered those neurons just before that?
The stimulus.
Then, zoom out. What were the hormone levels like in the hours or days leading up to it? Did that make the brain more or less sensitive to that stimulus?
Hormonal context. Got it.
Then keep zooming out. How did experiences earlier in life, maybe even back in fetal development, shape how that brain responds?
Early development.
What about the person's genes? And not just their individual genes, but the genetic tendencies of the population they come from, shaped by evolution.
Genes and evolution.
Well, okay. And what evolutionary pressures over millennia sculpted those genetic tendencies in our species. You see, we push it back and back and back.
So you start with the action and trace the influences backwards through time, from milliseconds to millennia, using all the different perspectives.
Precisely. And doing that constantly reminds you that saying it's caused by X, whether X is a gene, a hormone, a neuron, an experience, is just a shorthand. It's just the most convenient label for the sum of all the influences that came before it. There are no real buckets, just that continuous flow.
That really fights against that reductionist tendency, doesn't it? The idea of finding the one cause.
It absolutely does. It pushes back hard. It reminds me of the ideas in that book, Chaos, by James White.
Great book about complexity theory.
Exactly. For centuries, science often worked on a reductionist model, right? If you want to understand something complex like a clock, you take it apart. Understand the springs, the gears, the hands, then put it back together.
Understand the pieces to understand the whole.
Right. But Gleich and others argue that some systems aren't like clocks at all. They're more like clouds.
Clouds. How so?
You don't understand rainfall by capturing a cloud, dissecting it into individual water molecules, and studying them in isolation. You understand it by looking at the dynamics, the interactions, the larger patterns, the whole system.
The emergent properties.
Yes. And behavior, especially human behavior, is much more like a cloud than a clock. You can't just break it down into genes or neurons and expect to fully understand it. You need this different, more integrated, dynamic way of thinking.
That's a powerful analogy. Behavior as a cloud, not a clock, requires a different mindset.
It really does. A radically different way of thinking is needed to truly get behavioral biology.
So we've gone through the complexities, the approaches, the pitfalls. Let's bring it back to the person listening right now. Why should they care about all this? Why is understanding behavioral biology important if you're not, a scientist?
Because, honestly, you are a behavioral biologist all the time.
Yeah.
Every day.
How do you mean?
Think about it. If you ever serve on a jury, you're trying to understand someone's behavior, their motivations, their state of mind. That's behavioral biology.
True. Assessing responsibility.
When you vote on social policies, how should we deal with crime? Addiction, mental illness, poverty. You're making assumptions about the causes of human behavior. That's applied behavioral biology.
Okay, yeah. Policy rests on ideas about why people do things.
Or even just in your own life. Trying to understand a family member who's struggling with depression. Is it purely biochemical? Is it their life circumstances? Are they, as some might unfortunately think, just indulging it? How you answer that shapes how you interact, how you offer support.
Right. Your personal theory of their behavior matters.
Exactly.
Right.
So understanding this stuff, even at a basic level, helps you be a more informed citizen, a more effective voter, maybe a more compassionate friend or family member. It gives you a lens to see the nuance, to resist those easy, categorical answers to really complex human questions.
It equips you to navigate the cloud rather than just looking for the gears.
That's a great way to put it, yes.
So as we wrap up this first part of our deep dive, maybe the thought to leave everyone with is just that, reflecting on this incredible complexity. How might starting to see these invisible biological threads, the hormones, the genes, the ancient evolutionary echoes, the split-second neural firings, and consciously resisting that easy urge to categorize, how might that change how you personally approach understanding yourself, or understanding other people, or even thinking about the big social issues we face? It's not about finding simple answers, but maybe about appreciating the vast, intricate tapestry that makes us human.
Well said. It's about appreciating the whole messy, fascinating picture.